All right, Chapter 4, Training Circular 9237, Section 4, Welding, Brazing, Soldering, Non-Ferrous Metals, Aluminum Welding. Generally, aluminum is readily joined by welding, brazing, soldering. In most instances, aluminum is joined. Conventional equipment and technologies used with the other metal with however specialized equipment and techniques may be sometimes required. Alloy joint configuration, strength, required appearance, cause arc factors, or factors of direct hitting, choice of the process, each of the process with the current advantages, limitations. Characteristics of aluminum. Aluminum is lightweight with retained with a ductile sub-zero temperatures, also high resistant corrosion, good electrical, thermal conductivity, high reflective to both heat and light. Pure aluminum meets at 1220 degrees Fahrenheit, whereas aluminum alloys any of the approximate melting range from 900 to 1220 degrees Fahrenheit. There's no color change in aluminum when heated, welding, or brazing range. Aluminum forms of pure aluminum can be alloyed with many other metals to produce a wide range of physical medical properties, means which with the alloying elements strengthen the aluminum U at the base for the classify the alloy of the two categories, non-heat treatable and heat treatable. Raw alloys are formed of the sheet of the plate with the tube and extruded with the rolled shape of the forgings and similar with the joining characteristics. Regardless of form, aluminum alloys are produced with the casting in the form of the sham with the permanent mold with the die casting. Substantial same welding, brazing, soldering practices are used in both cast rotting metal. The die casting have not been widely used for the welding construction and the required, however, they have adhesively bonded to limited extent with the side of the recent development of the vacuum die casting have improved the quality of the casting to the point with the satisfactory welding in some applications. Surface penetration, since aluminum has great affinity with the oxygen film oxide of the presence of the on its surface of the film removed prior to the attempt of the weld braze the solder of the material that must be prevented with the form during this joining procedure. In the preparation, aluminum with the welding, brazing, or sanding scraped off the film with the sharp tool of the wire brush for the paper with the similar means. Due to the inert gas generation, application flux prevents forms of oxides during joining processes. All right, gas. General. The gas welding process most commonly used for the aluminum and aluminum alloys, oxyacetylene, oxyhydrogen. Hydrogen may be burned to oxygen with the same tips used in acetylene. However, the temperature is lower than larger type tips is necessary. Oxyhydrogen welding permits wider range of the gas pressure with acetylene without losing desired slightly reducing flame. Aluminum from 1/32 to 1 inch thick may be gas welded. However, the heavier metal material is seldom gas welded. The heat of disposition rapid. It is difficult to apply sufficient heat with the torch, which is compared with the arc welding. Welded metal freeze rate with the gas welding very slow. Heat input with the gas welding is not concentrated with the other welding process unless the precaution for the taken great distortion may result. Missed distortion is obtained with the edge of the corner welds. And this shows the approximate condition of gas welding in aluminum. Or your edge preparation. Sheet of the plate edge must be properly prepared with the obtainment of the gas weld maximum strength. Usually prepared with the same similar thickness with the steel. However, the material of 1/16 of an inch thick over the edges can be formed with a 90-degree flange. With the flange prevent the excessive warping of the buckling and the strip of the metal during the welding. Without filler rod is normally limited with the pure aluminum alloys, since the welding and cracking can occur with a high strength alloy and gas welding thickness of 3/16 of an inch. Edge should be beveled to secure the complete penetration, including the angle of the bevel with a 16 to 100 degrees. Preheating of all the parts recommended with all the casting plate with a 1/4 inch thick over the will avoid severing thermal stresses and ensure the good penetration and satisfactory welding speed. Common practice of the preheat with a temperature with 700 degrees Fahrenheit. The material should be warmed and welding torches should be prior to the welding. Even a slight preheat helps to prevent the crack of the heat treated alloy should not be preheated above the 800 degrees Fahrenheit unless post-weld heated treated. Preheating above the 800 degrees will cause a hot short. The melting and the melt strength will deteriorate rapidly. Preheating temperature checking technique. The pyrolytic equipment, the temperature for the gauge if it's not available, the following test can be made to determine the proper preheat. Char test. We're using a pine stick with a rubber end of the stick with the metal with the preheat of the proper temperature of the stick will shower the darker the char of the higher the temperature. Carpenter's chalk mark the metal with the ordinary blue carpenter's chalk with the blue line will turn white at the proper preheat temperature. Hammer test. The tamp of the metal light with a hand hammer with a metal that loses the ring with the proper preheat temperature. Carbonizing test. Carbonize the surface of the metal, suiting the entire surface as the heat of the torch is applied with the suit disappear with the point of the suit disappear with the metal surface slightly above 300 degrees Fahrenheit. The care should be taken not to coat the flux area with the suit. The suit can be absorbed with the weld and cause porosity. Welding flame. Natural, slightly reducing flame recommended for the welding. Aluminum oxidizing flame will cover the formation of aluminum oxide, resulting in pore fusion and defective weld. Are your welding fluxes? Aluminum welding flux is designed to remove the aluminum oxide film with the oxygen with the vicinity of the puddle with the flux of the gas welding, usually poured former and mixed with water with a form of thin paste. Aluminum welding flux should be applied with a sheen with a by brushing with a sprinkle with a spraying with the other suitable method of welding rod should be used. The coated with the flux will melt with the below the welding temperature for the metal with the protective coating on the surface with the puddle with the coating breaks up the oxide prevents oxidation permits slow cooling of the weld. Warning: as the solution, you remove the aluminum welding brazing fluxes after the welding of the brazing. The toxic and highly corrosive goggles, rubber gloves, rubber aprons must be worn. Handling of the acids in solution: do not inhale the fumes that slip with a spill on the body of the clothing and washes immediately. Large quantities of the water seek medical attention. Never pour water into acid when preparing solutions. Instead, pour acid into water. Always mix acid and water slowly. These operations should only be performed in well-ventilated areas. The aluminum welded flux contains chlorides, fluorides, and the presence of the moisture will attack the base metal. Therefore, all fluxes remain in the joint, so after welding must be completely removed. The welded readily accessible to clean all the boiling water. Fine brush of the parts having the joints located. The cleaning of with the brush. Hot water is not practical. Maybe to cleanse with the acid dip, the cold water, hot rinse, and 10% sulfuric acid cold water solution, 30 minutes to 5%, and the sulfuric acid hot water solution in 5 to 10 minutes for this purpose. For 5 to 10 minutes for this purpose. Welding technique. After the material was welded properly with the prepared flux and preheated with the flame of the base of the small circuit over the starting point until the flux melt, the filler rod should be scraped over the toe of the surface of 3 or 4 seconds for the interval, permitting the filler rod to come clearly from the weld, from clear to over the flame each time. Scraping action reveal the welding of the starting with the overheated aluminum base metal with the melted before the filler rod is applied. Forehand welding is generally considered the best weld of aluminum. So the flame will preheat area to the weld, and the welding thin aluminum. Little is needed with the torch movement other than progressing forward with the other material. 3/6 of the torch should be given a uniform lateral motion. This will distribute the welded metal over the entire width of the weld. The slightly back and forth motion will assist the flux to remove the oxides. The filler rod should be dripped into the welded puddle periodically with the drawn in the puddle from the forward motion. The method of the withdrawal closely of the puddle prevents porosity, assists the flux, removing the oxide film. Art 1120. General. The many aluminum alloys can be brazed with aluminum brazing alloys to provide aluminum alloy structure that is excellent corrosion resistant with a good strength of the appearance of the melting point of the brazing filler metal with relatively close than other material being joined. However, the base metal should not be melted with the result of the close temperature control of the necessary for the heightened temperature required with the aluminum assembly is determined by melting points of the base metal with the brazing filler. Alright, commercial filler metal. The commercial brazing filler metal with aluminum alloy with aluminum base filler metals are available to wire and shim with the stocks. The conventional method of pre-placing a filler metal with a brazing sheet and aluminum alloy base metal coated on one or both sides with a heat treated with the core with a low layer composed mainly of magnesium manganese. Are also used. The third method of the brazing filler metal is used to paste the mixture of the flux and filler metal powder. Common aluminum brazing contains silicone with a melting depression of the wither without addition of zinc and copper magnesium. Brazing flux is required with all the aluminum brazing operation. Aluminum brazing flux consists of the various combination of fluorides and chlorides and it's supplied with dry powder. Towards furnishing brazing flux is mixed in with water to make a pave. The paste with the brush and spray with the dip and flowed onto the entire area with the joint. Brazing of the filler metal with the torch with the torch and furnace brazing fluxes are quite active. May severely attack the aluminum must be used with care. Dip brazing with the bath consisting of molten flux. Less activity fluxes can be used with the application of this components can be safely brazed. Alright, braze joint design. Braze joints should be lap flange, lock seam, T-type, butt scrape, butt scarf joints are not generally recommended. T-joints allow for excellent capillary flow with the formation reinforcement fillets for both sides of the joint. For maximum efficiency, lap joints should have the overlap at least of maybe least twice the thickness for the thinnest joint. Remember, they overlap at the greater than 1/4 inch, and they leave the voids for the flux inclusion. In this case, the use of the tray with the groove within the kernels and direction of the brazing filler metal flow and the beneficial close assembly show all the easy escapes of the gas of dip brazing with the entry of as well with the drain and flux. Good design for the long laps to require the brazing filament flow one direction for the maximum joint sound. If the joint design must also permit the complete post-braze flux removal. Hard brazing fixtures whenever the possible part should be designed with the self-load with the jigging with the fixture with the potential differential expansion with the can occur with the between the assembly with the fixture to store the part stainless steel ionical springs and often use the fixture accommodated difference expansion fixture material metal steel stainless steel higher with the repetitive furnace brazing operation for the dip brazing avoid flux bathing contamination fixtures of the nickel iconium aluminum coated steel and preferred pre-cleaning of the essential for the production strong with the leak type braze joint vapor soft cleaning of the usually adequate for non-heat treatable alloys, heat treatable alloys. However, the chemical cleaning with the manual cleaning for wire brush or sandpaper is necessary to remove the thinner oxide film. Alright, furnace brazing. Furnace brazing is performed with a gas oil electrically heated furnace. Temperature regulation within 5 degrees Fahrenheit necessary to secure the consistent result of the continuous circulation of the furnace atmosphere with the desired sense for the reducing the brazing time result with the more uniform heating of the products for the combustion furnace for the detrimental with the brazing utility, serviceability, brazing assemblies, heat treatable alloys. Alright, aluminum brazing continued torch brazing. The difference from the furnace brazing in the heat with it is local light with applied with the part with the until the flux of the brazing filler metal with melt with the wet surface of the base metal with the process resemble with the gas well with the concept of the raised filler metal is more fluid with the flows from the caliper reaction torch metal brazing is often used with the attachment filling of the previous well with the furnace brazing assembly with the joint of the return bend similar application dip brazing and dip brazing operation large amount of the molten flux for the help with the ceramic pot with the dip brazing temperature of the dip brazing pot are heat with internally with the direct resistant heating low voltage high current transformer to supply the alternating current of pure nickel alloy carbon electrode with immersed with the bath and such spots are generally lined with a high alumni cotton fiber brick or manufactured mortar. Alright, warning. The acid solution removed the aluminum welding the brazing plug, but after welding, raising of the tax are highly corrosive with the goggle, the rubber glove, and rubber aprons must be warm with the handling acid solution. Do not inhale fumes. Spill. When spilled on the body with clothing, immediately large quantities, immediately wash with large quantities of cold water. Seek medical attention. Never pour water into acid when preparing solutions. Instead, pour acid into the water. Always mix acid with water slowly. The operation should be performed in a well-ventilated area. Alright, post-brazing cleaning. It was always necessary to clean with the braze assembly since with the brazing flux with the acceleration corrosion left on the part for the most of the satisfactory way of removing the major portion of the flux and immerse with the hot parts of the boiling water as soon as possible after the brazing alloy has solidified the steam formed. Remove the major amounts of the residual flux. Distortion from the quenching of the is a problem. The parts are allowed to cool in the air before being immersed in boiling water. Remaining flux remove with the dip of the concentration nitric acid 5 to 10-15 minutes. The acid removed the water rinse preferably with the boiling water in order to accelerate the drying. The accelerated cleaning the method of the dip of the parts from 5 to 10 minutes with 10% nitric plus 25 hundredths of a percent of the hydrochloric acid solution at room temperature. The treatment also with the file with the hot water rinse. The brazed assembly consisting of a section with a thinner than 10 hundredths of 10 thousandths of an inch so the maximum resistant corrosion. Important with the common treatment of the immersion in the hot water followed with a dip in the end of the solution. 10% is the nitric acid, 10% sodium dichromate, and 5 to 10 minutes for the followed by the hot water rinse. The parts emerge with the hot water rinse immediately dry with a force of hot air to prevent staining. Art 1121, soldering. Generally, soldering is a group of the process of the joint of the material, the heating from the suitable temperature. The filler metal melt the temperature above 840 degrees below the melt of the joint. You use the filler metal distributed between the closely fitted surface of the joint with the caliper reaction. Solder is fusible alloy to join metal. The kind of solder used depends on the metal to be joined. The solders can be speltered. Hard soldering is called silver soldering brazing. In this process, gives the greater strength of the will, but you stand more than soft solder. Soft solder, the process used to join most common metal with an alloy that melts temperature below its base metal. Many respectively the operation similar brazing for the base of the not melted. It is merely tinned on the surface of the soldering filler metal. Before the strength of the solder of the joint depends on the penetration of the solder into the pores of the base metal, surface along with the consequent formation of the base metal of the solder alloy together with the mechanical bond between the parts. Soft solders are used the airtight, watertight joint for the not exposed with the high temperature joint preparation. The parts should be soldered should be free of all oxide, scale, oil, dirt to ensure the sound joint with the cleaning of the performed immersible and caustic acid solution filing, scraping, and sandblasting, fluxing. All soldering operations require flux in order to retain the complete bond with the full strength of the joint. The flux is cleaning the joint area to prevent oxidation. Creep the wetting power with the solder. The creep the surface tension. The following temperature soft solder fluxes are in common use: rosin, and glycerine. Rosin, and glycerine. They use the cleaning joints to prevent the formation of oxide during the soldering operation. Zinc and chloride, aluminum chloride may be used in tarnish surfaces of the permate. The good tinning of solution zinc of the cut in the hydraulic muriatic acids commonly used the tin work as a flux. The application of soft soldering joints may be made using the gas flame, wiping the sweat off the joints and dipping in the solder baths. Dipping is a particular application for the repair of the radiator cores, electrical connection, sheet metal, or with the solder with the soldering iron gun. Wiping of the method usually joining leading a pipe with the lead jacket underground or the lead cover cable to sweating joints may be made. Applying a mixture of the soft solder powder paste fluxes joints, heat with the part until the solder mixture with the liquefied flows into the joints. The mating surface of the members to be joined. Applying the heat to the complete the joint. All right, your aluminum solder in general. Aluminum-based alloys can be soldered and techniques that are similar to those of the other metal. The abrasion and the reaction soldering are the most commonly used with the aluminum. With the other metal, however, the aluminum requires special flux for the resistant flux of the satisfactory solderability. Aluminum alloys, most readily soldered aluminum alloys, cannot contain no more than 1% magnesium, 5% silicone. Alloys containing the greater amount of these consistent with the poor flux wetting characteristics. The high with the copper of the zinc-containing alloys having poor soldering characteristics because of rapid solder penetration loss of the base metal properties. Alright, joint design. Joint design used for the soldering aluminum assemblies with the cylinder for the used in other metal, with the most commonly used design form of the sample lap of the T-joint types of the joint clearance vary for the specific soldering method of the base alloy composition, solder composition, joint design flux, composed, employed. However, the guide joint clearance ranges of 5,000 to 20,000 inches required for the chemical flux that are used in 22,000 to 10,000 inch space and used with the reaction type of the flux used. Penetration of the soldering grease, dirt, and oil or foreign material must be removed with the surface of the aluminum before soldering. In most cases, the only solvent of grease is required. However, the surface is heavily oxide. Wire brushing with chemical cleaning may be required. Caution: caustic soda and cleaners of pH of 10 should not be used with aluminum or aluminum alloys as they react chemically. Soldering techniques. The high melting point of the solders normally use the aluminum assembly plus the excellent thermal conductivity of the aluminum dictate large capacity. Heat transfer source must be used with the bearing of the joint area with the proper soldering temperature of the uniform weld control. Heating should be provided with the timing of the aluminum surface that can be accomplished covering the material with a molten metal solder with the scrubbing of the surface with non-heat absorbing such as the gas fiber brush, serrated wooden stick with a fiber brick, fire block of the wire brush for the other metallic substance if they are not required. The tendency to leave the metallic deposit absorb the heat and quickly freeze the solder. The commercial solders of aluminum can be classified in three general types according to the melting points. Late temperature solder, the melting point of the solder is between 300 to 500 degrees Fahrenheit. Solders in groups contain lead, cadmium, and produce joints for the least corrosion resistant. Alright, your intermediate temperature solders. The solders between 500 and 700 degrees Fahrenheit. Solders with the group contain tin, cadmium, various combinations, zinc plus small amounts of aluminum, copper, nickel, and silver, lead. High temperature solder. These solders between 700 and 800 degrees Fahrenheit. The zinc-based solders contain 3 to 10% aluminum, small aluminum, other materials, copper, silver, nickel, and iron to modify their melting welding characteristics. The high zinc solders have the highest strength of aluminum solder for the most corrosion-resistant solder assembly. Copper welding. Copper have the high thermal conductivity heat required for the welding, approximately twice the required with the steel of a similar thickness to offset by the heat loss of the tip 1 and 2 side larger than required for the steel. Recommended with welding a large section of a heavy thickness supplementary heating divisible for the process produced the welded less porosity. Copper may be welded slightly oxidizing flame between the molten metal with the protected the oxide of the form of the flame of the flux used with the molten metal with the flame of the neutral oxygen-free copper with the deoxidized copper red should be used rather than oxygen-bearing copper for the gas welded. Some of the variety to use the same composition base metal. In general, and in welding copper sheet with the heat with the conductor away from the welding zone rapidly with the difficulty to bring the temperature up to the fusion point where they often necessary with the raise of the temperature lever of the sheet with up to 6 to 7 and 6 to 12 inches away from the weld. The weld should be started and some point with the way at the end of the joint with the welded back to the end of the filler metal with being added after returning the starting point of the weld before start and made the opposite direction of the end of the seam. During the operation, the torch should be held at approximately 60-degree angle with the base metal and advisable to back up the seam of the underside with the carbon block with the sheet metal to prevent the uneven penetration of the material should be channeled undercut permit the complete fusion of the base joint with the metal on the each side of the weld be covered to prevent radiation of the heat with the atmosphere that would allow the molten metal to weld, solidify, and cool slowly. Welding speed should be uniform. End of the filler rod should be kept with a molten puddle during the entire welding operation. Molten metal must be taken to the outer flame envelope, and the metal fails to flow freely during the operation. The rod should be raised. The base metal heated to the red heat along the seam. These welds should be started again and continue until the seam of this weld is completed. When welding thin sheath, the forehand welding method is preferred. The backhand method is preferred. Thickness of 1/4 inch or more. Sheet metal is up to 1/8 inch thick of the plane. Thick of plane joints or square edges preferred. With their thickness greater than 1/8 inch should be beveled, including angles of 69 degrees, with this to ensure the penetration and the spreading of the fusion of the wide area. Alright, copper brazing. Both oxygen bearing and oxygen free copper that can be brazed to produce the joint with a satisfactory property of full strength with a needle copper brazed joint with a developed and lap joint with a flame with it should be slightly carbonizing also with the brazing the alloy with the copper fluxes, copper phosphorus with copper fluxes, silver alloys brazed joint with the made with the flux through the use of flux with the result will result in a joint with a better appearance. But lap the scraft joints used with the brazing operation where the joint member of the flat round tubular or irregular cross section clearance that permits the penetration filler metal except with a large diameter pipe with its joints should not be more than 2,000, 3,000 of an inch. The clearance of the large amount of diameter pipe joinings may be 8,000 to 100,000 of an inch to 2.54 millimeters. The joint may be made and inserted with a filler metal. May be fed from the outside of the after the joint. The measure brought up with the proper temperature for the scarf is used with the joint band saws for joints whereas double thickness of lap is not desired. Alright, brass and bronze welding. Generally, with the welding of the brass and bronze, the different for the brazing welding process required with the bolt of the base metal with the edge of the welding rod, whereas the brazing only filler rod is melted. Low brass copper 80 to 95%, zinc 50 to 20% of the braze. This type of the weld is readily all position oxyacetylene process welding rod. Same composition base metals are not available for this reason. 1.5% silicon rods are recommended with this filler rods widely different with differs from the copper to the welding point progressively reduced with zinc and added fluxes are required. Preheating supplemental heating may be also necessary. High brasses 55 to 80% zinc, 20 to 45% of the brazing can be easily readily welded in all position. Oxyacetylene process of the welding rod is substantial with the same composition available. The welding technique with the same as required with the copper welding, including supplementary heating and flux, is required. Aluminum braze of the weld with the styled and welded with the oxyacetylene process. Difficult to handle with aluminum oxide with the flux of the design with the brasses. Success for the reported using welding rod with the same content with the base metal with the bronzing welding flux that has been added small amount of aluminum welding flux to the control of the aluminum oxide, copper, barium alloys, while the alloys by oxyacetylene process very difficult because of the formation of barium oxide. Copper nickel alloys for this welding standpoint, but the alloys are similar with the model with the oxyacetylene welding can be used successfully. The flame should be slightly reducing. Rod should be of some composition. The base metal sufficient to deoxidize or magnesium, silicone, and even to protect the metal during welding flux design. Specifically, mono these alloys must be used to prevent formation of the nickel oxide and to avoid porosity, liquid melting of the base metal. The desire for facility, rapid solidification, molten metal with one start with the weld that should be complete without stopping the rod should be kept with a protective envelope of the flame. Nickel, silver, oxyacetylene welding preferred method of joining alloys with the type of the filler metal with a high zinc bronze contains more than 10% of the nickel. The suitable flux might be used to dissolve the nickel oxide, avoid porosity. Phosphorus bronze oxyacetylene welding is commonly used with the welding copper tin alloy with a heating slow cooling cause of the contraction and consequently cracking porosity with a hot short material. However, the oxyacetylene must be used. The welding rod should be graded with an E 1.0 to 1.5% tin. The good flux of the type of the use of the brazed welding neutral flame and the preferred unless the appreciable amount of the lead present. In this case, the oxidizing flame helpful to producing sound well. A narrow heat zone promote the quick solidification of sound well. No hot short design fine with a marked loss of the strength with a high temperature below the melting point. Silicone brazing. Copper silicone alloy successfully welded by the oxyacetylene process with filler metal should be used the same composition base metal with the flux of the hydrochloric acid content should be used with a weld pool as small as possible with the maintain with the facility rapid solidification of the kept the grain side with a small avoid contraction strain of the hot short with the temperature range with the slightly oxidization filler kept within the keep the molten metal clean and the oxyacetylene welding of these alloys. The flame is helpful when welding in the vertical and overhead position. Art 1126, magnesium welding, gas welding. General gas welding magnesium is used only with emergency repair. Broken, cracked, can be restored, placed back in the reused and back into use. However, the repair is not only temporary, but the replacement part can be obtained. Gas welding has almost completely phased out of the gas shield. Arc welding which does not require corrosion-producing flux needed for the gas. Base metal preparation, same as that for arc welding, melting flux. Flux protects the molten metal with excessive oxidation. Repair with the oxidation protects the surface. Also promotes the proper flow of the weld, the proper wetting action between the weld metal with the base metal. With the one, most of the fumes do not react with the magnesium flux fused to rest stable. They do not react strongly after the cooling of the tacking with the mixture moisture. Therefore, after all trace of the flux and flux residues must be removed immediately after welding. Hard fluxes are usually supplied with a dry powder, hermetically sealed with a bottle with a prepared using mixing the water with the base of the good base consistently. We can produce approximately 1 pint of water to 1 pound of powder. Do not prepare any more than 1 day supply of flux paste. Keep it in covered glass container when not in use. The flux paste can be applied to work welding rod, small bristle brush when possible, or by dipping. The presence of a large amount of the sodium welding, given the flux of the intensity of the glare of the welding flame, operated with the most proper protective tie of the blue lenses are preferred in the goggles. Welding rods. The rod should be approximately the same composition for the base metal of the casting forge and fitting of the weld. The sheet of the form of the rod have the same composition metal as the sheet. It is necessary to stripe off the base metal, but it may not instead of the regular welding rod. The welding rod may be readily identified following characteristics. Dowel metal F is for blue. Dowel metal J and J1 is green, yellow, green, and aluminum. Dowel metal M is yellow. Maswell AM35 is round. Maswell AM528 and AM553S are square. Muslim A57 is triangular, and Muslim A887 is oval. Like all magnesium alloy, the welding rods are supplied with a corrosion-resistant coating, which must be removed before using after the welding operation. Tray with the flux, which should be removed with the unused portion of the rod, and then welding technique. Liberal coating of the flux applied with a bolt stop with the weld seam onto the welding rod with the torch should be adjusted with neutral, slightly reducing flame tack should be at space 1/2 to 2.5 inches apart, and intervals along the seam of the making the tack weld with the welding area should be heated gently with the outer flame of the torch to drive fuse flux. So use the harsh flame which may blow the flux away with the flux liquid inner core with the flare of the held with a distance of 1/16 to 1/8 of an inch from the work with the drop of the metal with the added with the rod. With the more flux will be required to finish the rod. The weld short the same manner with the tack weld. The weld should progress with a straight line, uniform rate with the speed with the torch held with a 45-degree angle with the work. The torch should be moved steadily while the rod is intermittently dipped in the welded pool. Then grief with the heat with the necessary with the vessel with the grief the angle with the torch for the work. Too hot of the flame and too slow with the speed and the grief the activity, viscosity of the flux. God with the pitting of the weld interrupted with the end of the weld should be refluxed and the flame directly slightly ahead of the weld before the restarting of the bead. All tack overlapping welds should be remelted, float away with any flux inclusion to avoid cracking with the starting of the weld before started away from the edge. Magnesium castings are to be welded preheated with a torch aimed at the furnace before welding, and the entire casting will be brought up to the preheated temperature of about 650 degrees Fahrenheit. The temperature approximated with the blue carpenter's chalk, which will turn white at about 600 degrees Fahrenheit. After the welding, casting should be stressed with relief in the furnace for 1 hour to 500 degrees Fahrenheit. With no furnace available, the gas flames should be used to heat the entire casting until the stress of the relieving temperature retreats, and casting should be allowed with the cool slowly and away from all drafts. Alright, warning, pre-cleaning, post-cleaning acids used in magnesium oil raising are high toxic corrosive. Goggle with rubber glove with rubber aprons must be worn. Handle with acid solutions. Do not inhale fumes or mist while spilled with the body with the clothing. Wash immediately with large quantity with the cold water. Seek medical attention. Never pour water in acid with the preparator solution. Instead, pour acid into water. Always mix acid water slowly. Clean operation which should be performed in well-ventilated areas. Hard cleaning after gas welding. All trace with the flux must be removed of the parts immediately of the completion of the gas weld with the first scrub with a stiff brittle with the hot water that immerses 1 to 2 minutes with chrome pickling solution consisting of 1/2 pound with the sodium chromate, dichromate, 1/4 pint nitric acid, enough water to make a gallon. Temperature of the solution should be made with 79 degrees Fahrenheit. After chrome pickling should be washed and the cool water should be boiled for 2 hours. After the solution of 8 ounces of the sodium dichromate and 1 gallon of water. Parts should be rinsed and dried. Alright, your magnesium brazing. General, the furnace torch or flux dipping brazing can be used. Furnace and torch brazings are generally limited to the M1A alloys. For dipping brazing you can be used the AX10, AX31B, K1A, M1A, and ZE10A alloys. Alright, brazing is designed to permit the flux of the display for the joint with the brazing filler, metal flow for the joint with the best joint for the brazing of the butt laps, suitable clearance of between the pairs for the sensor for the proper capillary filling action for the taking place. Suggested clearances from 4,000 to 10,000 of an inch. In furnace brazing, bare limited tab with the brazing alloy to avoid ignition with the magnesium. Equipment and material. The furnace and flux spots equipped with the automatic control that maintain required temperature with the plus or minus 5 degrees from the torch brazing standard with the type of the gas used. Chloride-based flux is similar to the gas welding and suitable for the special flux required with the furnace brazing. Fluxes of water and alcohol-based unsuitable for the furnace brazing. Magnesium-based alloy filler metal is used with the core characters of the braze joint similar to welded metal, welded joint, and other good resistant against corrosion. Alright, base metal parts. Preparation. Parts to be brave with the parts thermally clean and free of the substance for the oil, grease, and dirt. Surface of the film for the chromates and the oxides. Pre-cleaning, post-cleaning, even the magnesium welding, brazing, highly toxic, corrosive with the goggles, rubber glove with the rubber with the aprons must be worn. Handling acid solution. Do not inhale the fume of the mist of the wind spill with the body. With the clothing washed immediately, large quantity with the cold water. Seek medical attention. Never pour water into the other preparation solution. Install the pores acid into the water. Always mix acid water slowly with the cleaning operation. Should be performed only in well-ventilated areas. Mechanized cleaning of the accomplished sanding of the aluminum oxide of the cloth of clothing. Chemical cleaning accomplished with vapor, decreasing alkaline cleaning, acid solution containing consists of 24 ounces of the chromatic, 40 ounces of sodium nitrate, and 1/8 of an ounce of calcium or magnesium fluoride within water, and make it 1 gallon. Is suitable for this purpose. Parts are immersed in solution 79 degrees Fahrenheit for the 2 minutes, and then rinse thoroughly with the first cold water, then in hot water. Are your brazing procedures towards the equipment technique of the gas welding? You the brazing magnesium neutral oxyacetylene with a natural gas air flame may be used in some operation. Natural gas is preferred with a soft flame, less for the danger of overheating. The filler needle is placed with the joint flux before the melting and added with the means of the flux core filler rod. If the rod is used with the flame of the directed at the base metal of the rod is dipped intermittently into the molten flux puddle. The furnace of the parts brave with the assembled fellow metal is placed around the joint with the flux pour fully power form as part of the joints. The parts are placed in the furnace and the bracing temperature of the bracing time 2 to 3 minutes depending on the thickness of the parts being brazed. The parts are air cooled after removal of the furnace. Flux dip. The joints are provided with a slot with a recessed groove with edge for the filler metal to prevent being washed into the flux bath of the parts. Of then assemble the fixture through thoroughly dry them, immerse in 30 to 45 seconds of the molten bath and flux. Cleaning after brazing, remove all the traces of the flux. Essential with the flux residual hydroscope will cause the pitting of the type of the corrosion. With the parts should be cleaned with the same manner of the parts, gas welded parts. Alright, general welding, magnesium alloy can be soldering is limited to the filling with a small surface defect for the casting, small dents and sheet metal with the other minimum treatments. The surface of soldering may not be used to stress area with the joint. Magnesium and other metals because of the low strength and brittle joints obtained. Soldering procedures, magnesium alloy surfaces must be clean, brittle, metallic luster before soldering to ensure good self-fusion between solder and magnesium. This cleaning is accomplished by the filling wiring brush aluminum oxide cloth. The area to be soldered should be heated with just above the melting point with the solder with a small quantity of the solder applied with the rubber vigorously over the area to obtain the uniform tin surface. Stiff wire brush or sharp steel tool assists with the establishment of the bond. After the bond is established, filler metal may be applied, may be added to the extent the desired flux is not necessary. Alright, your nickel welding. Generally, nickel alloys can, for the most part, the weld is the same process with the carbon steel, the oxyacetylene weld with the preferred metal arc. In some cases, the true welding of the thin wall pipe with the tubing and the thin gauge with the wears arc with the penetrative of the material is also preferred to the high carbon steel because of the lower welding hardening results. Joint design. Corner and lap joints are satisfactory with the high strength. They're not encountered with the butt joints are used in equipment that dispense pressure for the vessel. Beveling is not required with the butt joints. Material of the 50,000 to 125,000 an inch. Thick material, the bevel angle of 37.5 degrees that should be made for sheets of 43,000 hundredths of an inch of the thinner bolt. Both butt corner joints are used. The corner joints are used in thickness of 30,000 an inch or heavier. Fluxes is not required with the welding nickel, however, it is required for monal and inconal. The flux is used preferably with a formal thin paste made with a mixed dry flux of the waste of the monal with a thin solution shellac with accomplished 1 pound of shellac with 1 gallon of the alcohol. Used an inconal with a welding K monal with the flux composed of the 2 parts of the inconal flux. 1 part lithium fluoride should be used with the flux applied within a small brush swab with the both sides of the seam, the top, bottom, and on the welding rod. Welding rods of the same composition alloy with the welding are available. The rods of the same composition necessary in 2, the uniform corrosion resistant without galvanic effects. In some cases, some separate special silicone metal wire is used with welding nickel. Welding technique: oil, dirt, and residues must be removed from the area of the weld with machining, sandblasting, graining, rubbing with abrasive cloth, and chemical pickling. Alright, your slightly reducing flame should be used with a slight pressure for the fluctuation of the main oxygen settling regulator. The amount of settling of the flame should be used only enough to counteract the fluctuation, prevent the flame from becoming oxidizing in nature. The tip should be the same size with one side of the larger, but recommended with the torch manufactured similar thickness for the steel. The tip should be large enough to permit the use of a soft flame, high velocity, harsh flame, undesirable. The parts for the weld should be held firmly in the place for the jig and clamps to prevent distortion. One side of the welding should continue along the seam with the remove of the torch from the work. The end of the welding rod should be kept within the protecting flame and the envelope of preventing oxidation. Heat rub the luminous cone tip of the flame with the contact strip of the molten pool in order to obtain the concentrated heat. With this event with the pre-oxidation molten metal with the pool should be kept quiet with the non-portal below the surface of the oxide slag with the form. The surface of the molten metal with the rod should be melted into the weld under the surface of the film. Alright, 11:30. The nickel soldering. Soft soldering can be used with joining nickel and high nickel alloys only with a sheet metal not more than 1/16 of an inch thick. Only with the application where the soldering is not readily corroded with the soft solder. Inherently low strength with low joint strength that must be attained with a rivet lock seam. Sand spot welding with welding soft soldering acting with sealing medium. The 50-60-40% tin lead solders are preferred joint metals of this type. Flux sheet with nickel mono zinc saturated hydrochloric and muriatic acid solution in column requires stronger flux because of the chromium oxide film. The all flux and flux residues must be removed with the metal, but after the soldering operation is complete, surfaces of metal parts of them must be soldered, must be free of dirt and surface oxide with other discolorization when possible. For the surface of the joint, there should be tin and solder to ensure complete bonding during the final soldering operation. Lead welding. Generally, welding lead is similar with welding other materials except that no flux is required. Processes other than gas are not in general use. Gas is a combination gas commonly used with lead welding. Oxyacetylene, oxyhydrogen, and oxynatural gas. The oxyacetylene and oxyhydrogen processes are satisfactory for all positions. Oxynatural gas is not used for overhead welding. Low gas pressure ranging from 1.5 to 5 psi in general using depending on the type of the weld to be made. And then the torch. Welding torch is a relatively small size with an oxygen flammable gas valve located at the forward end of the handle that may be for the conventional adjustment of the thumb of the handle, holding handle with the torch tip. The range of the drill with the size of 78 to 68 with the same types of same tips for a 6-pound lead, larger tips, heavier lead. Welding rods. The propeller rods are same composition of lead to be welded with the range side with 1/8 to 3/4 inch in diameter. The smaller side with the lightweight with the larger side with a heavier lead. Type of the head joint for the butt lap edge joint is the type of the most commonly lead welding. Either butt lap joint with the flat position weld with the flap joint is vertical or overhead position with the edge of the flat joint is used only under special conditions. Alright, welding technique. The flame must be neutral with the reducing flame and leave the spot with the joint with the oxidizing flame with the reduce the oxidizing molten leave it impair the fusion. Soft brushy flame the most desirable welding horizontal position. More pointed flame with generally use the vertical overhead position. A flow of molten metal lead control with the flame with usually handled with a semicircular V-shaped motion. Account with a herringbone or core appearance of the lead weld. The direction of welding depends on the type of the joint, with the position of the weld. The vertical point lap joints start with the bottom of the joint. Welding joint is not generally used. Lap joints are preferred in flat position while the torch is moved in a semicircular path toward the lap and then away. Filler metal is not on the first path of the overhead passing position. Welding is very difficult to position. Lap joint, sharp flame used. The molten beads must be small. Welding operation must be completely quick. Alright, white metal welding. Generally, white metal is divided in 3 general categories according to the base of the composition. Zinc, aluminum, magnesium. Most of the casting is made with the zinc alloy type. This aluminum melting point is 725 degrees. Flame adjusting welding. Flame adjusting with the carbonized the knot should be deposited on the joint. Oxyacetylene flame is much higher than necessary. It is important to set like a very small tip welding rod. It may be pure zinc of the die casting alloy with the same type of the welded the metal flux. 50% zinc chloride, 50% aluminum chloride can be used, but is not mandatory. Alright, your welding technique. The casting should be heat the metal, but begin with turn the flame with a parallel surface along the side of the flame. Keep the metal soft while heating the welding rod at the same temperature. Both of the base metal with the welding rod at the same temperature. The rod should be applied thoroughly with a few of the walls. The joint of the rod should be manipulated with a break the surface oxides and bronze surfacing. General bronze surfacing is used for the welding of the surface that have been worn down with the sliding friction. Other type of the wear the low heat conditions prevail. Type of the repair does not involve the joining of the metal parts. It is merely additional brazing bronze on metal in order in order to maybe restore original size and shape of the bronze surface of the piece of the machine to the desired prime and finished dimension. Cast iron, carbon, alloy steel, raw iron, malleable iron, mono, nickel, copper base alloy satisfactorily built with unless the process is prepared with worn surface the rocker arm, the roller, lever bearings, gear teeth, shaft, spindles, yoke pins, clevises, small bushings removed, then filling up the hole with the cast iron with the bronze, then drilling them out the required size. Alright, preparation of the surface is rebuilt with the machine to remove all scale on the dirt other than foreign material. The mass post possible the cast iron surface should be cleaned, shipped and cleaned them with the paint matching machining of the will smear with the surface of the graphite, particularly with the presence of the cast iron, making bonding difficult. The cast iron surface must be machined. The oxidizing flame should be passed over the surface to burn the other surplus graphite, carbon, before bronze coatings. Applied hollow piston head casting should be vented, removing the core plugs and drilling holes in the cavities. This will prevent tap gases from being expanded, welding, heating, cracking of the metal. Alright, flame adjustment. Neutral slightly oxidized flame is recommended, but the excess acetylene flame will cause porosity and fuming. Flux is suitable brazing flux should be obtained with a good timing and adhesion with the brazing on the base metal. Welding run bronze rounds should fulfill the requirements for hardness and ductility needs for the particular application. Bronze surfacing metal is usually applied with a mechanical means that accomplishes even the two more flame. The straight line of the oscillation motion layer of bronze 1/16 to 1/4 inch thick is usually sufficient. It should be slowly cooked, slowly cooled to the room temperature, then machined desired dimensions. Chapter 12: Special Applications.